Hey, parents and students, I just wanted to make this video for you guys because of my screw up on the homework from earlier this week where I assigned problems in the Professor B work but that we haven't done yet. So I just wanted to kind of bring you up to date so that you're not feeling frustrated with these. So just a quick recap of what we have talked about in class so far, which is there are three basic types of percent problems. You can have a problem that says something like 27% of 83 is what number? And again, we mentioned that you could say what number is 27% of 83. We could have that question so that the what part comes at the beginning or the end. So that's one type. And the second type is where we have 27% of what number is 15. And then there's a third type that we could have that would say what percent of 35 is 17. All right, so in each of these cases we have something that's missing, and depending on what is missing, it's going to depend. That will determine how we solve the problem, not how we set it up, but how we solve the problem. So in each percent problem, when we're taking a percent, it means we're taking a fraction of something, or a decimal amount of something, and so that something that we're taking the percent of, in this case the 83, that's called the whole. Right, that's the whole thing that we have to work from. And then this is obviously the percent part. And then this right here, when we take the percent of the whole number, we get the part. Again, they might have other words for that. If you look something up on YouTube, you might find other words that they use for that. But generally we say that we're taking the percent of the whole quantity that we have and we're getting just a part of it. So in this case, it's the part that's missing, all right? Because we say 27% of, it's always the whole number that we're taking, even though it's not a whole number necessarily. It could be 83.7. It doesn't mean that it doesn't have a decimal with it or a fraction with it, but it's just, this is the whole quantity that we have. So it's always the percent of the whole quantity gives us a part of that amount. All right, so here we're missing the part. In the second problem here, or in the second question, we don't know what the whole is, but we know what percent we're taking of it, and we know what piece of it we end up with, or how much that piece of it is. So in this problem, we're missing not the part, but the whole. Sorry, that looks kind of weird. All right, and then the third situation, it's what percent of the whole is this part of it, and so what's missing is the percent. All right, so this first type we have done before. We did that last year. You learned that last year in Fred. We did word problems on that type earlier this year. You remember that there was that one trick problem on that worksheet, and then we just did a worksheet on this last week. So this one I feel like you're pretty confident with, but it's these two that that we've not done that much of. In fact, we haven't done any of the third type. And in this one, we just started some in class but didn't even get a chance to finish it, and yet this was what the entire assignment was on, and so I really want to focus on that. But just I want to also point out in general that there are different ways to solve these, but the kind that we're going to focus on is where we take and we translate this sentence into a math equation. Again, I know there's one that's is over of equals percent over 100. We haven't learned ratios yet, so I'm going to hold off until next year to do that. And so what we're going to work on is just translating these sentences from math into English, and then we'll solve from there. So let me just translate this one. Actually, we'll do the first two. Again, I'm going to skip this one because we haven't done it yet, but if we translate this first sentence, let me write it over again. 27% of 80, let me just stick with 83, is what number. And the way we translated that in class was we just went through and we literally went piece by piece and we said what it is. So 27% is 27%, but we said it's probably more useful for us to write it as a decimal. And again, you could also write it as a fraction, which is how you saw them last year. You would write 27 over 100, but the problems that you got last year were nicely divisible by 100. All right, and 83 is not, and so it's more helpful this year to do them as a decimal. We also discussed how of in math often means times. So again, I'm going to put the dot there because we use the X to represent this number. 83 is just 83. Is, or any form of the verb to be, translates into equal. Most often, again, we said, if it says what is the weather, it doesn't mean what equals the weather. It's usually just in a math sentence that works that way. All right, so 27% of 83 is what number? And then we picked a variable. Again, some of you liked W for what number. Some of you liked N for number. I often use X just because. Right, and so then we ended up with this equation that says 0.27, and I'm going to use parentheses instead of the dot now. 0.27 times 83 is what number? And then we just used our decimal multiplication to come up with an answer for that. So we would get 83 times 0.27. 7 times 3 is 21, 56, 58, 0, 6, 16, 1, 14, sorry, the glare, I can't read this, that's 12, right, and then we put our decimal, and so we would say that the number is, we could say X equals 22.41, or we could just say 27% of 83 is 22.41. All right. And the shortcut here is when both numbers are around the multiplication symbol, then you just multiply. All right. Even if I didn't tell you, you would probably realize that 0.27 times 83 just means multiply the two of them together. Okay. Hopefully you feel good about that. Again, we've done a number of those in class together. All right. The second type, 27% of what number is 15, is going to translate a little bit differently. So let me rewrite that down here. 27% of what number is 15. And again, we're going to translate it. This translating will be so helpful in most of all the word problems that we do, which is why I'm focusing it, another reason why I'm focusing on that more than this one, even though this is more formulaic. I just think this is also a really nice skill for us to have. So 0.27 multiplied by what number? Again, you fill in the variable of your choice. I'm going to fill in an X. Is, that's going to be the equal sign, and 15. All right, so again, let me rewrite this without the dot. Now that makes more sense to do that because then I've got 0.27x. I don't need to write anything between it if it's a number and a variable. Equals 15. All right, so again, in class yesterday, we refreshed our memory on the fact that when we have some number times a variable equals 15, the way that we solve for that is that we divide both sides by whatever that number is. And again, we refreshed our memories by remembering that when we were doing that with repeating decimals, when we were converting repeating decimals into fractions, we had something like 100n equals, and then we had n equals, and then we had some number here, I don't know, let's say 6.232323, and then we might have had, I don't know, boy, I should have just made it a single digit that was repeating, just to make it easier, and I'll just make it 10. I'm just trying to prove a point here. So 6.2222, and then we said we had 62.222, and we on this side we subtracted and we got 9n, and on this side we subtracted and we got 56. All right. And then to solve, we said, hey, to get that n by itself or to find out what it is, we divide both sides by 9. It was easy here because it was a whole number, and so that made a lot more sense to us, and we would have gotten n equals 56 over 9, which we could then just convert into a mixed number, which would be 6 and 2/9. All right. My point in reminding you of this is that when we have a number multiplied by a variable, something that we're looking for, to get the answer to what it is, we divide by whatever that number is. We call that the coefficient of the x, right? You're getting to learn a little bit of algebra right here in Math 6. So we would say that we're just going to divide both sides by that number, because then when we do that, 27 or 0.27 divided by 0.27 is just 1. Anytime we have identical numbers being divided, it gives us 1. So this turns into x, and then we would just have to do 15 divided by 0.27. So again, we use our decimal division skills. We'll put that 15 in here. I'm going to have to move this over 2 places. Move the decimal up. I'm just leaving a couple extra spots in case it doesn't, it's not a whole number. So let's just do that. So 27 goes into 15. Nope. Goes into 150. Yes. Hold on. All right. I'm going to count by 25s just to get an estimate. So 25, 50, 75, 100, 125, 150. That would go, 25 would go into 150 6 times. 27's bigger, so I'm going to go with 5 times. 5 times 7 is 35. Put down the 5, carry the 3. 5 times 2 is 10, plus these 3 is 15. We subtract, and we get 15. Oh, interesting. This is going to be a repeater. So then this is going to be another 5, 135. Subtract, we get 15. Bring down the 0, we get another 5, so we end up with 135. We can end up saying that it's 55.5 repeating. All right. If it doesn't repeat like this, if it keeps going, I would say just go one more spot and then round. So let's say this didn't repeat and we found out that this was, let's say, a 7. Instead, we would just, instead of continuing to go on, we would say, oh, to round, I look at this place, right? I want to round to this place. I look at his neighbor. If his neighbor is 5 or above, we bump this up to the next one. We say 57.57 is closer to 0.60 because I've passed the halfway point. I'm either at or past the halfway point. So in this one, it repeated, so we could just write the repeat bar. But if it doesn't repeat, go one more digit past the tenths place and then decide to either keep this if we haven't yet reached the halfway point, or bump it up one if we've gone to the halfway point or beyond. Okay, the last type you would set up the same exact way. Well, let me just say this. So here, I guess the short version is if you don't know both numbers around the multiplication symbol, which we don't here, we only know one of them, not 2 of them, then to solve, you must divide to get the missing number by itself, or that missing variable by itself. And the same will happen in this third type. I would translate this, what percent of 35 is 17. I'm hoping that we'll have time to look at this in class on Tuesday, because there's nothing different about this than this, except in the end we need to turn our answer into a percent because it's asking for a percent. And so we'll end up getting a decimal, and then we'll have to say what is the percent version of this decimal. Right, so this looks like it's going to be somewhere close to 1/2. So in fact, let me change this to a 34 to make it a little bit nicer. All right, and so we would say, okay, well, I have to divide both sides by 34. Again, you might say you want to write this as 34x equals 17 instead of the way I have it written here, but we would divide both sides by 34, and I would get x equals, and then I have to do this division. So I'm going to do that. 34 into 17. I have to put the zeros. All right, 34 doesn't go into 17, but it will go into 170. And I'm going to guess 5. Again, I'm doing front end estimating there. 3 goes into 17, just the front end part goes in 5 times, so that's a good guess. Right, 5 times 4 is 20. Put down the 0, carry the 2. 5 times 3 is 15, plus 2 is 17. Nice. So we get x equals 0.5, but remember, in a type like this, they want to change it into a percent, and so we would say, oh, 0.5. Well, in order to change it to a percent, I have to take 0.5 and multiply it by 100%. Our fancy one. And in doing that, I would get 50%. All right. So that, again, well, I'm hoping that we get to work on those on Tuesday. Okay, I just want to say one more thing, and that is also part of the homework were a couple word problems. So I wanted to look at ones like that. So here is a sample of one that is like, it's not exactly the word problems in the workbook, but it's similar enough to that I think it'll get you off to a good start. So in one particular neighborhood, there are 13 families that own a beagle. If these owners make up 65% of all the dog owners in this neighborhood, then how many dog owners are there in the neighborhood? Round your answer to the nearest whole number if necessary. We don't want a fraction of a family. We just want to know what the nearest whole number is. So again, it's saying that in this neighborhood, wherever that is, that there are 13 families that own beagles. So I don't know. We'll just put 13 beagle owners. I can't even draw a beagle, so I'm not going to try. But they're 65% of the dog owners. So again, if we were to think about what this looks like as a fraction, again, this is not necessarily, I'm going to draw a nicer rectangle, commit to this. So we've got this neighborhood, whatever that looks like. 65% of the dog owners, so own a dog that's a beagle. So here would be 50% if I cut that in half. So I'm going to make it a little bit more than that. And let's say this is about 65%. All right, so I can say it's 65%. I can also say it's 13 owners. Sorry. All right, so the question is, how many are there altogether? So if I were thinking about this problem, if you're thinking about the problem, again, we would say what percent of the whole is the part? And then we would say, well, what do I know? All right, so do I know the percent? All right, well, yeah, I do. I know it's 65% of the whole. Do I know the whole amount of dog owners in the neighborhood? Well, hopefully you're saying no, because you only know how many own beagles, and that's just part of them. Maybe these own, I don't know, a French bulldog. Maybe they own a chocolate lab. So this would be other dog owners that are not the beagle owners. So we don't know the whole, we just know the part. So I don't know what that is. So 65% of what number is, so then I must know the part. I have to know 2 of them. I can't be missing 2 of them. I can only be missing 1. So, and again, we could, this checks that this is the part. It's not the whole amount of dog owners in the neighborhood. It's just some of them. It's only the ones that own the beagle. So we would say, yeah, I do know the part. It's 13. All right, so 65% of what number is 13? So we need to think as we're doing these, do I know the part? Do I know the whole? Do I know the percent? You'll know 2 of them, and you have to figure out which ones they are, but then you're just going to fill them into this question. What percent of the whole is the part? And so then you know how to fill them in. All right? So here we would say, well, then if we translate that, that becomes 0.65 times what number? X is equals 13. All right. Usually when I translate it, I write it that way with all the symbols there, but then after that, I just skip to 0.65x equals 13. You might decide that you want to skip that step and just say 65% or 0.65 of, know that it's multiplication, but you can just put them side by side, is the equals and 13. All right, then again, because I don't know both numbers around the multiplication symbol, again, there's the multiply. I know one of them, but not the other one. Then that means I have to divide to isolate this. I'm undoing the multiplication by dividing. So I'm going to divide both sides by 0.65. 0.65 divided by 0.65 is 1. Anytime we have a number over itself, it's just 1. So this becomes x equals 13 divided by 0.65. All right, now I'm going to translate this into a number. And so I do that by division. So inside goes the 13, outside goes the 0.65. Oh, that was really far away. I just put extra places because I don't know if it's going to end up being a whole number, in which case we don't need these two. I need the 2 in order to move the decimal point over. I might need these 2, I might not, so I just usually put them there, and sometimes I don't need them and sometimes I do. All right, so 65 does not go into 13. It does go into 13. It goes into 13, I think 2 times. All right, and so then we end up with 130, all right, and which is lovely. And so we get a 0 here. We bring down another 0. Don't forget, you need to fill in all the places up to where the decimal is. So even if this is a 0, you have to make sure that you say 20, not 2. All right, so that we end up with x equals 20. Now we have to be careful to make sure that we're answering the question. This x stood for the whole number of families, all of the families in the neighborhood. So don't say that this is 20 right here, right? That's how many don't own a beagle. That's not what they asked us. They asked us how many dog owners are there in this neighborhood. So we want all of them. So the whole amount of dog owners in the neighborhood is 20. So we would say there are 20 dog owners in the neighborhood. Right, now you could answer other questions. They don't ask us how many families are there that don't own beagles. That we could answer if we say we know this is 20, so now this has to be 7. Right? So don't think that we would have to stop there. Usually we stop with the question that they ask us, but we could fill in other things. But here's the thing that they're asking us. There are 20 dog owners in the neighborhood. Okay, I hope that that helps clear things up and that you feel a little bit better about these percentage problems. Also, there's homework on Monday where you're going to have to do ones that are more like this, right? So hopefully this helps. All right, have a good weekend.